Okay. Well, good evening, everyone. Welcome to the November meeting of the Rotary E-Club of Southeast USA and Caribbean. I'm A.Bostdorff-Miller, president of the E-Club. And this evening, I am very, very pleased and proud to introduce our speaker. Give you a little bit of background on him, other than the fact that I've known him literally all my life. Mr. Richard Bostdorff was raised in Northwest Ohio. He did his undergraduate studies at The Ohio State University. From there, he actually moved to Orleans County in upstate New York and became a county agricultural extension agent through Cornell University. He did finish graduate studies soon thereafter the move at the University of Missouri in Columbia. After a few years, he moved to Oregon State to be part of that state's agricultural extension program. And then after a couple of years, he moved to Florida's Gulf Coast and became an executive vice president in charge of research and development for an international plant growing company known as Speedling Incorporated, which is based in Ruskin, Florida. After a little bit more than 10 years, he moved back to Northwest Ohio with his lovely wife, Mary Ann, to start an independent business, Bostdorff Greenhouse Acres, which became a very successful greenhouse, nursery, and landscape company. Prior to his retiring, he started research and development on a greenhouse crop growing method involving strobe lights. He now has 2 US patents on his program, which will be part of his talk this evening. So there it is in a nutshell. And again, proud to introduce my father, Mr. Richard Bostdorff. Dad, the floor is yours.
Hey, thank you, Alicia. And welcome to all that I see on the screen there. What I'm going to try and do tonight is talk a little bit about food production in greenhouses and or warehouses and both. Because we, as our population blossoms, and it's blossoming every year, food production is going to become a factor in the long term. And with the present climate problems we're having, experiencing, energy, the increased need for water, which is becoming limited, nutrients, so forth, you cannot move inside structures without additional lights, at least to go into full-time production and so forth. And you have to realize that when we move into the inside production, about 45 acres of greenhouses is equal to 600 acres of outdoor production. In order to get that, you have to run 24/7, 365. And so now it becomes very important to get the night production. So lighting becomes the critical factor. Water is not so much, because we're going to collect rainfall and we recycle the water. We recycle most of the nutrients with a few additions. And of course, weather doesn't become much a factor. We can change the heat when we want to. We can have warmer, cooler, whatever. And even today, as we look at greenhouses, we think of those being in northern climates. Canada, United States. When you go to Europe, when you get in the Netherlands and that whole area up through there, this is what we call cold country. But today, since people want food produced locally and not shipped long distances, which is another use of energy, they're building greenhouses and utilizing warehouses locally in metropolitan areas. So the greenhouses being built in places like Georgia. There's greenhouses going to be built in places like Miami, Florida, next to the population, because it doesn't matter what the soil is. It doesn't matter what the climate is. You can make it what you want to make it. So even though we don't need heat in Florida, they do some cooling. So they're spending energy on cooling, and that's being done though through evaporative water cooling and so forth. So it isn't as bad as what you might think. So what I want to do tonight then is talk a little bit about the lights and what they do. And we have 3 lights we're going to look at tonight eventually as we get down the road here. and so forth. I want you to understand a couple things. One, lights, when we talk about lights, it's plants see lights differently than we see light, okay? And we measure that light in nanometers. Every color has a nanometer attached to it, okay? So if you look at this circle here, plants utilize about that upper half or the lower half. I don't care which one you look at, they're equal. So plants use all the blue down to the violet range and all the way up through reds and even high reds. So that's the range we're looking at. The blues range from about 300, 250, 300 nanometers, all the way up to the reds go up into 900 or so nanometers. So when you hear me talk about nanometers tonight, you'll know what we're talking about light spectrum wise. And that's very important that you sort of understand that, because plants, and we're just now developing the technology to learn what the exact nanometers of light a given species of plants utilizes. And we know in broad terms, like the vine crops, the cucumbers and stuff, they tend to be to the lower end. Tomatoes and the Solanaceae tend to be to the higher end. So you can focus your light if you wanted to, or pick your light if you wanted to, based on plant needs. We just don't have a lot of information on that. We have it on some crops. We don't have it on a lot of crops that we'd like to have it on, because it would make the job a lot easier from that standpoint. So we look at this. Now, when we talk about light, though, we're talking about energy. It takes a lot of energy to produce light. It doesn't just come easy. And the old greenhouse lighting systems that we had were called high pressure sodium. Basically, that's the real workhorse, has been for years and years. You go back lots of years and you'll find out that high pressure sodium, 1,000-watt bulbs, 400-watt bulbs. Now that's very interesting. We measure and can compare lighting systems or lights themselves based on wattage. So we're going to take a look tonight from the highest to the lowest, and some of the new stuff that's as good as the tall, but works on a lot less energy than what we have had to work with today. So when we look at what's light do to the plants, okay? Well, light does a couple things. Once in a while, we can change photo period. In other words, a plant needs a certain amount of light and needs a certain number of daylight, hours of daylight or hours of light. We can now say any given time during the year, we can have 12 and a half, 13, 14 hours, 15 hours worth of light. Therefore, we get results in growth. We get results in yield. We get results in quality. And the plant itself changes physiologically. The leaves get thicker, they get bigger for the most part, and they operate much more efficiently and effectively under the lights, because they do have an effect on it. Now, most of the lights we have sort of flood over top of the plants. So plants can utilize sort of the light that they receive, okay? Some lights, as you'll find out, are more penetrating. You have a small pinhole or something, force itself right through that pinhole and go into the center of the plant and just explode growth within. So plants get thicker and woollier. And from that, they become more efficient because they have more leaf surface to operate on. Okay. Now, we also can use the lights as deterrent to some of the diseases, because when that plant's growing, it's also producing other things in a way that makes the plant healthier. So we don't have the diseases to work with when we get inside these buildings. Now, we do have other problems though, because we drive the humidity up and we do all kinds of things, and that's a downside on to most of these things. Now, when we look at yield, I don't know of a case where we have taken light and added it to a crop that we didn't get a yield response versus no light. And that shouldn't surprise anybody, okay? Now, when we start talking between lights now, and it was mentioned earlier, the quality and kind of light will have some influence when we talk about different species, okay? So if you have bluer light, you get better cucumber yields than you would with tomatoes. We can take and put an amber lens on the same light and grow tomatoes because it just takes the blues out. So we know that it affects the upper range, which the tomato is a lot happier. Conversely, if we cut out some of the upper range, the vine crops are happier and produce better crops down here. So we have lots to learn. It's just a pinnacle, a little pin of what we knowledge that we know that we need on lights going into this. And as far as long as we are, we should have known this a long time ago. You know? But it wasn't necessary. We didn't have the energy problems. We didn't have the environmental problems. We didn't have the structures, frankly, to grow these crops in. If you go back and look at the history of greenhouses, at Cornell University in 1965, when I went there, we developed the first plastic covered greenhouse. Until that time, it was glass. And glass was very expensive. It was hard to handle, broke easily, but it was a great cover for greenhouses because it let the light through. But it was in little panes, about so big. And as a result of that, there was lots of shadowing in the greenhouse because all the rafter bars and all the parts between these panes of glass. So when we went to plastic, it opened up a whole new world. Well, it opened up another world too, because now when we went to double layer plastic, we cut our heat loss in that structure by 50%. We went from 1.5 BTUs per square inch per hour in glass to 0.7 in plastic. So that's why you see a lot of plastic houses today. Now you also see a bunch of glass. And the modern glass, however, most of it's being made in China. Interesting enough, the Chinese have developed a system, and you can send your specs over to China and they will make the glass to your specs. And all they're doing basically is changing the lead content. So the further north you come, the less lead there is in the glass. You get more sunlight through. The further south you go, like we talked about Florida and Georgia, the more sunlight you have and you want to shade that house just a little bit, you put more lead into the glass. And there's a natural shading due to the lead content of the glass. And that's important to know because it gets hot in the south. You all know that. Those that have been in Georgia, Florida, Texas, wherever, it gets miserably hot. And greenhouses don't help that situation at all. I mean, they're going to be hot too, and it's hard to ventilate those houses. And you never can get them less than what the temperature is outside. And so you have to do the best you can to keep it down as much as you can. So they're doing it by adding and subtracting basically lead. Now there's other ingredients too, but lead is the primary ingredient in the glass that helps them adjust the temperatures that they're facing. Now, when you look at the amount of light that it takes in greenhouses, it's fairly high. You'll drive around and someone mentioned, and I forget who, you can see this glow. This glow is nice. I like the glow. It's pretty. You know, I'm going to show you some glow in a minute here, but the glow is pretty. But the people who live around the greenhouses don't like this so much. It sort of bothers them at night. They suppose they can't sleep and they can't do a lot of other things. So there's regulations coming to food production in greenhouses, at least. Now we haven't talked about warehouses, but in greenhouses, that says you're going to have to cover them greenhouses at night. You cannot let this arrogant light out to just go into the light and light the world. We have a greenhouse, a big Dutch greenhouse, about 45, 50 acres, just 20 miles from us. When you go outside tonight, it looks like a city. Looks like a city going over there. That's not acceptable anymore. Okay, so now we're having to develop lights that actually direct or focus their light in a given area. And we do this by putting in different kinds of reflectors, either in the glass or outside reflectors. Well, I'll show you one here in a little bit. So it tends to direct this light down and doesn't let it escape up or out if possible. Now that's a problem because most of the lights in the greenhouse have to be 7, 10, 12, 15, 20 feet above the plants because that's where the structure is to hang the lights. Well, that's not necessarily where they should be because you'll see in a minute, a lot of these lights don't travel very far to be effective. Okay, you have to be fairly close. LEDs, for instance, must be much closer to the target that you're pointing them on than you do with HPS. HPS can be further away. The light will travel much further in an effective amount than LED does. LED has to be fairly close. And you should see this, you see it in your houses, you're growing plants under LEDs. You get down pretty close to that plant if you're going to be successful with LEDs in your house. It's no different commercially. Commercially, they still have to be close. That presents its problems, okay? Now, there are other ones coming. We're going to show you some strobe lights in a little bit, which sort of fit in the middle of things. They don't have to be, nor do they want to be quite as tall as 20 feet above the plants, but they don't want to, they can be close. So it's more versatile from that standpoint. But we need a lot of light. We measure lights lots of ways, but tonight I'm going to use candela or candle power, because most people understand that one candle is one candle power. All right, so it's an easy thing to do. And well, getting into all this and stuff with moles and moles per square meter per second and all the rest of these things, which you're not going to understand all that. So we'll use candle power tonight. All right, candle power is just a measurement. It's a measurement of what that light is giving off. Okay, and we're going to look at this. And let me just show you a little bit to start with, then we'll backtrack a little bit here. I want to start with showing you a little bit about HPS. High pressure sodium. High pressure sodium comes in two forms, basically a 1000 watt bulb and a 400 watt bulb. That's commercially. It gets, there's other than that. Lots of street lights and stuff are HPS. They're cheap. The bulb's cheap. The fixture's cheap. This fixture here, which weighs probably about 10, 12 pounds, costs about $300. Okay, and the bulb's a big old bulb in that. You've all seen them. There's no difference. And when you plug them in, they're going to start looking like that. Now, the downside to this thing is it gives off a tremendous amount of heat. Tremendous amount of heat. It also takes 3 minutes to reach peak light. Okay, so you can't flash it, you can't strobe it, you can't do anything with it but put it out there. So heat and energy consumption on a 12-cent kilowatt hour electric cost, this will use 1 kilowatt electricity per lamp per hour. So that means that in our electric bill that we look at right today here, it's going to take 12 cents an hour to operate this one light. Okay, and you're going to put these on about a 10 by 10 in the greenhouse. So an acre is going to have 400 or 500 of these lights per acre. Okay, so you can see what's going to happen. It ends up being millions of dollars to light a greenhouse, because greenhouse lighting this time of year, right now, takes place, and it's going to be turned on about 4 o'clock in the afternoon and won't be shut off till about 8 o'clock the next morning. So you're getting lots of hours. And if you got many of the lights, you're going to be paying Mr. Energy a whole lot. Now, that's a cost factor. That's a big cost factor. And it's put some people virtually out of business. And that's why LEDs, when they came along, was supposed to be the savior of all that's going on, because they're operating at about 60% less than an HPS. And that's using what we call a 640 LED or 650. They could be different sizes, but that's 650 watts. So we're running this at about 12 cents per unit per hour. The LED is going to be running in about 7 cents per unit per hour. Now, the other thing here is you can only put about 4 of these, maybe 5, maybe 6, depending on how you're put together on a given circuit. So it takes lots of circuits in a greenhouse to make this system work. LEDs, obviously, you can put more circuits on because you're using less energy. It's all based on watts and amps. Okay, so let's take a look at LEDs once, and then we'll get back to some more comparisons here. Okay. there's LEDs. Okay, that's the glow you see. You'll see the diodes. These are all little diodes. There's all different colors of them. One of the problems that we have a little bit with LEDs is there's not much green in the LEDs, and they're just now producing green colored LEDs or green colored diodes, because green is a great color in photosynthesis. It's one of the primary colors that you need. Don't need a lot of it, but you need some of it. Now, HPS has that because it covers the waterfront. Okay, LEDs give also heat. There's fans. It's a fan system, so you didn't really get away from the heating aspects of this thing when you went to LEDs, but you did lower your energy cost by about 40%. Well, 40% is a big bill. An acre of greenhouses, you could, run year round in the cold parts of the country, you could spend millions of dollars on electric. Okay, so you could lower it with LEDs. LEDs, now come back here, I don't know if you can see this or not, but HPS, this top little graph I just roughed in, HPS has a sort of an arc like this, and it's lighting. LEDs has two peaks. They have a blue peak and a red peak, basically, with a sort of a slump in the middle, okay? So here's the blue end, and here's the red end up here. Now we're going to go down and look at strobe lights here in just a second. That's this one here. And we're going to throw this into the mix. Now this is new. This is the one that I developed here. I didn't develop the system, but I developed the lamp and what it's used for. This is nothing but a glass tube with xenon gas in it. Xenon gas, then we ignite it. We don't burn it, we just excite it, I should say. And by exciting it, it gives off then the nanometers of light that it's capable of, which is actually about 280, maybe 230, all the way up to over 900. So we can get down into the violets and also up in the super reds with this light here. Now, this is what this looks like. Okay, that's going to pulse at about 80 to 90 times a minute. And that's a very, very penetrating light. That's a light that's driven. If you have any waxy surface or any surface they can bounce off of, you get lots and lots more out of what we would with strobe lights. Now, strobe lights are pretty energy efficient. This is for the people who have LEDs. This is going to compete with them because, again, I said 1 kilowatt hour, 60% of that 7 cents. This operates on 0.013 cents per fixture per hour. 0.013. It has a bigger nanometers of light than anything else we have on the table. You have a light that's $300, a light that's $1,500, a light that's $900. So you can compare them from that standpoint. We can put 30 to 40 of these on one circuit. Okay, another advantage, and it all plugs into your outlet. No special wiring. You don't need 220, 240. Plug it into your home outlet, and it goes. So it's versatile from that standpoint. So that's the three lights that's in the industry today. Now there's others in there. I mean, there's fluorescent lights, and there's forget one of the others, but there's several other lights in there. But these two are the common ones right here. And this is the one that's coming into the marketplace. Matter of fact, we're marketing it now. Energy is going to be the key factor in production of food in the future. Okay, it's there already. So this is going to be one of the things that we're going to look at. Great for all. We haven't found a crop that it doesn't respond to yet. Okay. The big operations we have, a couple of them have put some of this in. Alicia, why don't you roll a couple of pictures there just to show them what we have going. And the picture you're going to see here coming up soon Okay, this is what it looks like in a greenhouse. Now this greenhouse had HPS in it, and we changed the greenhouse over to strobe lights simply because this operation here is 100% driven by solar panels. So as a result of this, we can use this because there's low need for a lot of light. This whole greenhouse now can be run on solar power. We could not run this HPS lights on solar power, or we could run on solar power, but it wasn't big enough to go ahead and support the system. Same way that he had LEDs, he's now done away with all the LEDs and all of his HPS, because he can not have to buy extra energy over his solar panels to operate the lights he needs in the greenhouse. Mike, show him the solar panel one, Alicia. The boom running here is what we're applying water and or nutrients with in the greenhouse. Very, very high class, high technology is going on. When that thing goes down, turns around, comes back to itself, you don't have to touch it or anything. And the lights are all up and out of the way, so you don't have to worry about lighting as far as the crop is concerned. Okay.
I'll get the solar panels up in just a minute.
Okay. All right. So if we look at then crop production and we get increases of 20% or better, we see there's a difference between here, not so great on yield differences, but bottom line differences. The bottom line difference is going to be in the energy. The house costs the same. Now, if we move to warehousing, we talk about warehousing. Warehousing is even a different monster because you get no sunlight. And we're really trying very hard to develop lights that mimic sunlight, because Mr. Sunlight has it all. There's no question about this. It's the best. We will come as close to sunlight with this fixture because it's putting out, when it flashes, 1.6 million candles. Okay, 1.6 million candles. That's a lot of light. And the next one off the assembly line will be 20% greater than that yet. So it's very bright, very penetrating light. And so we're moving with this technology here to closer to sunlight, which in a warehouse is important because there's no support in the warehouse of sunlight. In the greenhouse, we're really supplemental lighting because we're just lighting at night. In the greenhouse, you've got to light 100% of the time because there's no sunlight coming in. But that also says, okay, my next problem is all this heat that's giving off over here. We have to do something with the heat that you're generating with these fixtures here. So now we have to spend more money on fans to exit the heat because it's too much. So now we have another cost of doing business here of exiting heat produced by these lamps. Okay. Now, interestingly enough, all this heat given off, this one here will tend to heat the air around where it's working. This one here tends not to do that, but it will increase the leaf temperature by about 3 degrees, where that light's touching the actual leaf. The leaf temperature goes up about 3 degrees. So if you go to Europe, they run their tomato houses at about 68 degrees, run the high pressure sodium, which doesn't increase the temperature in your house, which needs to be about 71 to 72, or the tomatoes won't pollinate. They won't get any fruit. But the plant compensates for that by 3 degrees on the leaf surface of its own. It recognizes that as temperature, and therefore they get away with a little cooler house over there. Fruit set, tomatoes are happy because the leaf temperature is up. Okay. Downside of this, no heat. It's a cold light. So it has its downsides also. If you want heat, can't use it. It isn't going to do anything for you. It just produces light. That's all it does. It does it, very cheaply from that standpoint. Now, the next thing we need to take a little look at when we get to warehouses and stuff like this is the fact that what do we do when we look at 24 hours Is there too much light? Can we get too much light? And the answer to that is yes. Yes. So we're in a process now of trying to learn what plants need as a dark period. And some plants badly need a dark period. We're doing some work with hemp now. Marijuana. It must have 4 to 5 hours of dark time, or it just is unhappy. It doesn't function well. It doesn't produce well if you don't give it that 4 or 5 hours of rest. Okay. Tomatoes, on the other hand, do much better if they get about 3 or 4 hours of rest. Don't need it. They'll still produce, but the fruit size goes down. So now we know that, yes, they're happier with a rest period in there. Well, that's okay. We don't need the rest period. Mean we're not buying electricity. We're not using energy in that case. So we don't know very much about a lot of these crops and what they need from a rest period and how much light they need. So we have a long ways to go, is all I'm trying to say tonight to you. We have a lot of knowledge, but we know there's a lot we need to learn about crops and production of plants and so forth. We also know that we need to start our plants in the greenhouse and the warehouse from when they're seedlings. We need to put light on them when they're seedlings. They react to this light when they're just popping out of the ground. And you know, we try to grow a 4 to 6 week old plant before we move it from the seedling house to the grow house. If we like them plants in the seedling house, before we move them to the grow house, we can pick up about 10 days of time in flowering or reproduction. That's money in the pocket. That's money in the bank. Okay. Tomatoes react to this. Hemp tends to react to this. Many crops react to the seedlings being lit before they go into production. And interestingly enough, if they don't go into a lit production facility, or even if you take them outdoors, we take to a field, that 6 weeks of energy we gave them still shows up out in the field, even though they never got another ounce of electricity or light. It's interesting, they carry it. So we can take it in, all right? We also know, and we're finding out more about this, that we may not need constant light in those hours ahead of that dark period. We may be able to have light for maybe a few minutes, because the original work done with some of these lights, especially this one, shows that 1 minute of this flashing light, which by the way is very safe. Someone may be asking, well, you know, that's bothersome to see that light. If you're looking at people who are sensitive to that light, it takes 3 flashes per second to trigger any response in people that's not is a negative response. We're at 1 to 1.5, so we're half that area, so we don't have to worry about epilepsy fits and all the rest of that thing with this particular light. But it's all based on flashes per minute or flashes per second, whichever. So we're okay. And that's the pulsing thing. We can pulse this one here too, okay? Because it's on and it's off. And what I'm going to say to you is that we're going to find that that's even better, maybe, because we don't need that light. The original work done with this was done at Ohio State on pot mums and changing a photo period from vegetative to flowering, or flowering to vegetative, whichever way you want to look at it. And it only took 1 minute of flashing, 1 minute solid flashing, to add enough energy in that plant for that plant to grow sufficiently for 20 minutes. One minute of flashing gave enough energy into that plant for it to grow with all the energy it needed for 20 minutes. So all the research I did, I took it for 2 minutes because I was scared to try 1. That's cutting it pretty thin, I thought. So everything's based on 2 minutes with what we did here. We could do the same thing here, okay? I'm sure that it's possible to do this. Now, I say that, never tried it, okay? But based on the fact that plants can do absorb light and store light, this means that anything that we can then pulse, we can then cut the energy levels even further. because they don't have to be on all the time. They don't have to be on part of the time. With this one here, and I think we could do it with some others, we could get away with 6 minutes an hour is all we need this. Now we're talking about a cost of operation of 0.0007 cents an hour to operate one of these bulbs. Phenomenal. Savings is just out of sight when you look at that. These here obviously would be proportionally the same because you're starting out at 7 cents and you're going to ration that down. So it's possible, maybe. It's different. LEDs is a different cat, but the fact is it still is a light and it's a constant light. So maybe you could do that. Can't do it with this one because it has a warm up period. It takes 3 minutes to get warmed up. You shut it off. The minute you shut it off, that has 3 more minutes to warm up. It doesn't pop back. Okay. So that one's gone. And that one's really gone anyway. It's just costly. The original cost, the capital investment, that's pretty reasonable. $300, $1,500, $900. Pretty good, And that one there's going to cover, say, 64 square feet of greenhouse or warehouse space effectively. This one here is going to be less, but it just doesn't, and it has to be closer. So most of the time you're going to have, not only is it less, but it has to be closer. This one here is about half that. So in essence, you're going to, in some cases, we can change them one for one because the nanometers of light is very similar between these two fixtures. Okay, covered about the same. This will cover more, but they're enough alike that you could go to a greenhouse and say, okay, Mr. Greenhouse, we can do this. Further you get away though, higher, the less effective we become. Okay, with any of these lights, even these, we can get too far up and all that happens is it goes out. Okay, if you will look at this one here and this one here, because it's closer to the ground, we don't get quite that glow we were talking about. It's a lower glow than this one. This one here you see for, I said, 20 miles. This one here, yeah, you're going to be around, you're going to see it, you're going to drive around, you're going to see it. This one here, there's probably no glow because the reflectors are built into the lamp itself. So at 7 feet above the crop, we have a footprint of 4 by 8. Outside that, there's virtually little to no light going outside that. So we have now pulled the light in so that all the light becomes effective, not just part of it, the rest of it going out into the atmosphere where does no one any good. Okay, so there's what you have as far as light's concerned, and greenhouses and warehouses and what's happening with those kind of things there. Let me just check here, make sure I got to give you everything. I can't leave you hanging here with just a few. I think why don't we stop there, Alicia, a little bit and see if there's any questions, and I'll roll back.
Okay, that's fine.
Yeah, Dick, let me ask you a question. How high above the plant does the strobe, can you mount the strobe before you begin to lose the power of its reach? So I noticed in that warehouse
we think at this point somewhere between around 10 feet, you'll start to delineate down. It's really solid at 7 to 8 feet. 9, you would start thinning out, but it's still very effectively. 10, I'm saying you're going to dilute it. You're going to dilute it down. On the present lights we have, the new ones coming out at 20% greater, you probably go to 10 feet, be okay. Now you start diluting it at 11, 12, 13 feet. But most of the greenhouses and warehouses, you have to realize, Brent, you're within 8 feet of a structure that you're going to mount them on anyway, right. Or 10 feet. The big Dutch houses, they run up to 16 feet, 20 feet in the air, but they just have to put lots of those into those houses up there because they're too far away. They have to just fill that void with all the light they can.
Yep.
And they don't want these here. Their LEDs don't work well on tomatoes. They're tomato growers. They can take them and put them in their cucumber house and they're happy. So the big Dutch houses that growing tomatoes, they're not very happy with LEDs. something's not right about them. Just like this one here doesn't do lettuce real well. Something about that light that we don't know. Lettuce loves LEDs. It grows the most phenomenal lettuce you ever want to see. These will not do that. Those will not do that. They'll grow lettuce, but not like LED. So something in the LED spectrum, that lettuce plant just loving it up. We don't know what it is, but we know it exists. So you won't see many lettuce growers that aren't on LED now, as far as extra lights.
Dad, you have a question from Corey. What is the cost difference between the current model and the new model that's coming out for your strobe?
There may not be any because there's some built-in efficiencies in making the lamp. We're going to have a better reflecting system. The reflecting system is going to be built into the actual light itself. These are actually external. They're external. If I tore this apart, you'd see them in there. They're external to the light itself. This tube. They're going to be built into the light itself. So when you do that, you have a whole lot more efficiency because it's all machine done. There's some hand work in these here. Okay. I doubt it would be much different. It certainly won't be cheaper in the long run, but I don't think you're not going to be more expensive. I don't think.
Any other questions?
I have a
question. Yes. Yes.
I have a question. You haven't covered the nutrition part of plants yet, but do you foresee this item being available to like for homes? Like I'm a gardener. I love to grow vegetables, and I have a little place where I start my seeds with the LED light. But I have a shed, and I'm thinking, what a wonderful idea for a small family to have a shed and to be able to utilize that lighting and grow their own food. I mean, I think this is absolutely phenomenal. I'm just so impressed. And
we're doing that now. Matter of fact, we're doing a joint program with BGSU on their taste panels and the produce that's being produced under the lights, so that we will come up with produce under all of these lights, and they're going to run it through their taste panels. So we'll be able to answer your question better. There are also 3 hydroponic fish operations, which obviously grow fish, but they're also growing food, tomatoes, peppers, and other things. They're using these lights now because they have to have lights for not the fish, but they have to put lights on there to grow the plants. So the hydroponic people have to have lights now too. And we're looking at the food quality coming off of that. And that's, again, a joint program with the universities that we have under tow at this point. But you're right. And adapted to homeowners, there's no reason why, if they can afford, they don't need this kind of an LED. This is a commercial LED. You can buy much, much cheaper, smaller LEDs and do almost as well. And these here are available. I mean, but that's a lot of money, $900, but they do work. We have sold some to people who have little sheds, as you want to put it.
Yeah.
Put a couple in a little shed. But that lamp runs 30,000 hours. That's a lifetime of light almost. We're up to 40,000-50,000 hours in LEDs. If you figure that out, you're going to run it 8 hours a day. That's a lot of days, I guess. That's what I'm saying to you.
May I ask you what the diameter of one device, like the one that you have there? What is the diameter?
Area hung at 7 feet. Now, if you go lower, the footprint gets less. You go higher, it's going to get broader. At 7 feet, we're 4 by 8.
Okay.
4 feet by 8 feet. Effective lights. This one here, well, they're all going to be in that same ballpark. This one here is going to be much, because you have to get it closer to the plant. This one here can be higher. You put this at 10, 12 feet up there, or 16, 18 feet up there, it's probably 64 square feet per light. Okay.
Okay. And these can only be used for hydroponic growth. You wouldn't use them with soil. I mean, is there a way that you can use plants in soil and use that lighting with the soil?
Oh, yeah. But the media doesn't make any difference.
Okay.
to the light, okay? Matter of fact, we have some operations in California that were growing marijuana last year that they were growing outdoors. They took the lights right outdoors. They use it outdoors. There's nothing unique about having to have a greenhouse or a warehouse to put these in. You can take them outdoors. Especially the newer ones where we have really focused light. It'd be tough to take that one outdoors. It's just the light's going to be
Right.
gone here.
Right.
LEDs, same kind of thing. There's lots of shade light out, but you could take it outdoors. This one we know we take it outdoors. We've taken it outdoors.
Oh, I'm fascinated. I think it's so revolutionary. It's just wonderful. And I'm just really impressed, very impressed. Thank
Well,
you.
thank you.
Thank you.
Bertie, Dick and I worked and set up a lab and a student residence hall on our campus with that LED and that strobe. And the quality of the plants that came out of there were ridiculous. We put them in our community gardens to feed the food insecure. And we also grew flowers for downtown Bowling Green. And the produce that came out of there, I'd never seen anything like it. The tomatoes grew into hedgerows. I mean, it was just, and the marigolds were like nothing that anybody had seen before. So that between that Lambert media that he uses and that lighting and that controlled environment, it's just incredible. It's so your sense that it's pretty miraculous is right on. He's taught me so much in the amount of time that we've worked together, and the students were so enthralled. We're rolling out another one of these classes in the spring, and I've got to buy a couple more of the LEDs. We're so excited to have him, but the technology is really, really powerful.
You do realize one of the things with lighting, no matter what lights they are, it's going to take a little more nutrients. It's going to take a little more water because the plant's growing 24/7. So it's not a freebie from the standpoint of other inputs, okay? Nutrients and water especially. It takes that. We know that. We can measure plants. Dry weight matter goes up. Well, if it goes up, that means we've used more nutrients. We've used more water to build that plant up. So when we start lighting, we need to put other inputs, more of the other inputs in. So lighting, I just picked lighting because the others are, we can spend a whole night talking about nutrients. We can talk about water. We can talk about all these things, and we might want to do that sometime because I feel comfortable doing those kind of things. But light is a beast by itself. Okay, it has its own problems. It creates its own problems with the other factors involved with growing plants and what happens. Plants just get bigger and bolder, and the stems get stronger and bigger, and they do grow differently under lights. And it doesn't make a lot of difference what light, but the cost makes a difference. Cost of doing it, okay, makes a difference.
Richard, Richard, I'm just curious. What years were you at Oregon State University, and were you in Corvallis, or were you at one of the out experiment stations?
I was in Salem. I covered the Willamette Valley in vegetable production. I was the vegetable person for the valley.
And when was that?
That was in 77, 78, 79. And then the state went broke. So I didn't I didn't lose my job, but I might as well have.
I graduated there in 71, and I was, at the time you were there, I was in graduate school at Washington State University, and then subsequent to that, I've had interaction with Oregon State University through my position with the U.S. Department of Agriculture. But I was just curious whether we crossed paths at any point.
We could have, but we didn't, I guess, at that point. But yeah, that's when I was there. And then I left there and moved out to Florida.
Yeah, Alicia, I might talk with you sometime. I think your dad might be a good candidate for the Alumni Legacy Award for the College of Agriculture there at Oregon State University. I was I was privileged to be awarded that distinction in 2018, and maybe you and I can get together and with Richard's help, put something together.
Well, we definitely could do so. We need to set up a meeting anyway, because I need to award you your Paul Harris pin, so
Yeah, thank
we can
you.
set up a good talk. Any other questions?
Do we have the other pictures, Alicia?
I'm gonna see if I can pull them up from my phone. Hold on one moment.
What I want to show you is the, one of the fellows I'm working with now is 100% solar on his green. He has 3 acres of greenhouses, which is a lot of space. He's 100% solar panels. And he doesn't want to go beyond the capacity of the solar, therefore he's moved gyrated to here. He dropped 100% of those out because the minute he turns them on, he has to buy electricity from the grid, and that's expensive. And he can produce all of his own he wants on his solar setup. So it's one of those things.
I'm working from my phone here, so please bear with me.
Dick, while Alicia's working on those pictures, I'd just like to offer that with more unstable climate and food insecurity being a major factor in the world, the ability to have a solar powered, low energy growing production area inside, for example, an old shipping container in a third world country, that's something that this system could actually make happen.
We are doing that, have done that, Will. We have used shipping containers in Oregon, and where they're growing plants in those. We put the lights in there very, very successfully. It's the neat thing about them is you don't have high ceilings, so you just get a lot of light. It bounces off the side walls. It does everything. So actually, you accentuate the little bit of light you have to put in there. You really accentuate the amount of light that you get out for what you're putting in. Yeah, it's very useful, no question about it. And you know, if we look at it from what we were talking about earlier, a little 40 amp solar panel would power a lot of these lights, because the light we're looking at here is only 0.2 of an amp. It only pulls 0.2 of an amp.
Wow.
So figure that out, what you could put out there. You can put a number of those lights out there.
Okay, I've got one.
They only weigh 2 pounds, so they're very lightweight. That's a solar panel that Donnie has at his operation, and that's powering 3 acres of greenhouses totally. He buys no power unless he goes over what it's capable of doing. And at this point, since he's changed lights, he's not overing his solar panels.
Great.
All right.
Okay. Yeah, any of those other pictures up, Alicia, or you're okay?
Well, I think we're okay with that. I will add other pictures, other stills to the recording after we're done.
We are seeing at Donnie's at this point a plant response where he is now shortening the life cycle of the plants from one stage to another. And in the greenhouse, that's just money in your pocket. There's money in your pocket. His hope is that, say, take a given crop like begonias, even the flowers respond to this. Some of the flowers respond quite well. If he could grow 1 crop of begonias, which generally now takes about 8 weeks, he could do it in 7 with lights that don't cost him a whole bunch. That means by the season's over, he could almost get 1 whole more rotations of begonias if that's the crop he wanted. And that's true of other crops that he has going too. You can pick up time with this. And that's to harvest in tomatoes. We pick up time. There's no question about this. We also pick up the number of fruit. If you look at a hand of tomatoes, the number of flowers I hand tomatoes, generally it's 4 to 5 flowers. Normally just under no lights at all, you're going to get 3 to 4. We've never missed when we put lights on with this light, that light we have. We've had these side by side. We'll still get the 3 to 4 here. We'll get 100% here. So there's something going on in that light, and we think that's just because we built a better plant. We have more energy in that plant, and therefore it's responding to that amount of food that it has stowed away in that time period that it's being lit. Anything else?
Dick, where was
Okay.
that, where's that automated system that we saw the video from? Where is that located?
It's in Delta.
Delta, Ohio.
Yes,
Oh,
yes. That's the Schmidt operation, or Schmidlin operation, Donnie Schmidlin. Okay, it is that operation right there. That's all ornamentals, by the way. That's a rooting operation there. And we are getting response to quicker rooting in plants, tentatively, with sort of tongue in cheek a little bit, because we haven't run a lot of trials, but some of the trials we have run shows much quicker rooting of those plants, those cuttings. That's again a plus, because as soon as they get rooted, they don't die off from all kinds of other nasty things that can happen to rooting beds. We have a fellow in Michigan that last year that he cut his rooting time in half with the lights. He's going to do more of it this year. That's phenomenal. I mean, that's just money in the bank. Oh, and he was on some high sodium. Took them out, put the others in, get a better response. So something in the lights, and we're not geniuses yet. And you know, if you go look at the LED people, the field people, and all these, they don't have the answers either. You can ask them the same questions you ask me. You'll get probably the same answers if they're truthful. They don't know. It works, and we'll find out why it works sooner or later. We keep pecking away at it. We'll find out, because you can't be around plants all your life and have them lit and not observe something going on that's positive. Well, it could be negative too, but I mean, the information's there. You just have to be smart enough to figure it out.
I have one more question. How do you regulate the temperature in this warehouse? How do you regulate the temperature?
Well, if you're using high pressure sodium and LEDs, which if they're growing marijuana and hemp, they have to have both. That's how much light hemp takes. It's a huge consumer of light. Okay, so they don't have to add temperature. They have to get rid of it. There's too much heat in those houses. Okay, so what we do is we replace that with this, and that tends to temper that whole regime, because you have no heat versus the highest amount of heat.
Okay.
Highest amount of energy use, the lowest amount of energy use. So they're not only spending the money here to light, but they're also spending a tremendous amount of money on evacuating that heat out of there with fans. And fans don't run on cheap electricity, frankly. They pull a lot of electricity. But otherwise, you'd have, in the warehouses where you're growing things like lettuce, you're going to have to add heat. And then you do it with, well, depending on how big you are, most of the time they're going to do it with forced air heating, or they could be doing it with boiler heat. But most of the time it's cheap heat. Okay.
Okay, thank you.
You're welcome. You're welcome.
Thank you.
Okay, great. I thank you very much. I've had a great time tonight.
Well, thank you, Mr.
Great
Bostdorff.
job.
You're welcome. Quite welcome. Anytime.
This was fun. I have one of my rare opportunities to come up to Northwest Ohio and visit with my parents, and being able to get this set up and enjoy this time with my father, and of course with my mom, has been absolutely fantastic. And I'm really happy to see everybody this evening, and I really wish everybody a good evening. Those on the board, we don't have a really directed scheduled BOD meeting this evening, but we do have a couple things that we can talk about if you'd like to hang on and join in. For everybody else, have a great evening. Again, thanks, Dad.
Welcome, thank you.
Thank you.
All right.
Excellent
Thank you.
presentation. Thank
Thank
you.
you. Very
Great
good.
job.
Thank
Thank you.
you. Good job.
Yeah,
Bye.
you're welcome.
Okay, I can